skip 7 through 12 for today. No, they'll be done. They're just have to be separate just because I'm kind of running out of time this evening. So let's go through the ones where I think will pose the most difficulty. Here's verifying. And if I'm not mistaken, verifying, we got more verifications. 29, 33, and 34 are also verifications. Okay. But 29 and 32, those are just simplifications, so those don't have an end in mind. Basically, these guys definitely have an end in mind. So these are all about steps. There's no multiple choice for these whatsoever. They're going to have to be step by step. Okay. And so remember what you want to do is you got only two strategies, right? You just want to make sure you get them down to sine or cosine. Okay, break them down to sine or cosine, and then if they are adding and subtracting, you want to just bring common denominators so that you can bring them together. Alright, and third, really just use any identities whenever you can. Alright, so let's break these guys down into, now I want to get 1 over cosine, so my guess is that I'm going to get secant maybe, or maybe not. They're not asking me to have secant. You know what, let's just start from, I think it's easier to start on the left. Okay, we'll go with the left and then work towards the right. This is a little too simple to start with. So I'm going to go this way. So let's go ahead and write him as he is. He is sine x over cosine x. And then this guy is being multiplied to 1 over, and cosecant is 1 over sine x. Okay. Now notice then what you're doing is, in one step, that's all you got to show. These guys cancel out. So now you have 1 over cosine x. There's nothing else to show. But this is where all your points are. You're showing me that you know what tangent of x is, and you know that those will cancel out, and then just you proved what you needed to prove. So you can actually just go put, like a double line there. That's what some professors do. If this was a longer proof, maybe you would want to put QED. It's kind of a fancy way of saying I proved that which is supposed to be proved in Latin. But anyways, let's see this guy. Now this guy, I don't have my actual identities in front of me. Let's see, can I wing this? Let's see, I feel like 1 plus cotangent equals cosecant squared. 1 plus cotangent. Okay, and that is true. So 1 plus cotangent squared of x equals cosecant. So this means alright, now this is not actually part of my proof. What I'm doing here is I just want to make sure that if I move this guy over, is he the one that's going to be negative? Okay, no. So what if I switch the order here? Okay. What if I then made this guy, let's move him over. So let's move 1 equals the cosecant squared minus cotangent. Okay, and so then what if I want these guys to switch? Well, if I do that, then what it means is that I can switch them like this. Okay, I can switch the order of this, but what it does is it makes this a negative, it equal to -1. Okay. Alright, so do I got that? That's exactly what I need. So this guy here, okay, this guy actually equals -1. Okay. So this means then that as part of my proof, what I would say is that this guy equals -1 over cosecant x. Now this is just kind of a sidebar, okay? And so if you show this work, you're showing me that you know how to switch and use the identities to make this happen. Because once you make this happen, this is easy, right? Because 1 over cosecant actually is negative cosine, okay? Alright, so you just needed to know that this is -1, alright? Cool, and then that guy actually is 1 over cosecant is just sine. Okay. All right. So those are two verifications. I know there's a few more. We'll tackle them later. Right now, what we'll do is we're gonna switch gears and go to yeah. These guys are kind of misplaced. They should have gone over with the other ones toward the back of the test, or back of the test review. So let's go ahead and solve these guys now. And I do have an answer key here, so we can kind of make sure that all is well. So let's go ahead and treat this. Now we're only looking for solutions from 0 to 2 pi, so we don't have to worry about the general solutions. We can just look at the primary. Okay. So we're going to add 3 to both sides, so that this is actually 1. Okay. So now what I want to do is, now I want to think of, I'm going to take the reciprocal of all of it, right? So I'm going to make this one flip, and so 1 over 1 is the same as, if you look at it like this, okay? So this means that, just flip them both. Now luckily, wherever cosecant is 1, sine is 1 as well. Okay, so we just want to find the angles where sine is 1. So you would go and refer to. Start to fall. Okay, that's all right here. Alright, so the first part of this video, my phone just died on me, so you won't see that part of the video. The audio is better, so you're gonna have to settle for this audio on this one. That's fine. So I was speaking to you as if the audio was going to be really good. On the first couple problems. Alright, anyways, where does it equal 1? It's very top. That's pi over 2. Is there anywhere else? Nope, that's the only spot. So that's our only answer from 0 to 2 pi. That's it. Okay. Alright. Okay, now this looks pretty fancy here. I'm just gonna play by the rules. Let's see what happens. Now I see that radical 3 over 2. Got a feeling there's gonna be some stuff canceling out, so let's see what happens. Okay. What do we got? We're gonna add 3 to both sides. Okay. Now, before you go thinking that this looks impossible, okay, it's not. What we're going to do is give it a common denominator. So I'm going to change this 3 right here in the step and just do 6 over 2. Okay? Now, you'll see that that negative 6 right there plus the positive 6 is going to cancel out. So, whenever you see something weird, just follow the rules. Let the machine of algebra just execute what it should. Okay? And you'll notice that this guy actually canceled out right there. And so, that's going to be 0. And you will just have negative radical 3 over 2. That's a great answer. Great possibility, because now I know that if it's negative, it's going to be in the second and third quadrant. And radical 3 over 2 is the pi over 6 family. So that's going to be 5 pi over 6 and 7 pi over 6, because those are the two pi over 6s that are in the second and third quadrant. Okay? Alright. So, and again, I'm just going from 0 to 2 pi. Okay, let's do a couple more. And then, I feel good. I'm just tired. Tired is better than being incredibly sick. Oh, that was bad. That was so bad. I had COVID a couple years ago. That was bad. But this actually was worse. This was worse. Because I could not get comfortable in my skin. And so I was I couldn't sleep, couldn't think, I could not get comfortable. It was just like, it felt like just feverish, couldn't stay warm, couldn't stay cool. It was just awful. Anyways, so definitely going to add a -6 to both sides. So we got -1. We're going to divide now by -1. I know you want to take the square root, but don't do it yet. Okay, so that will just be a +1. Okay. All right, so now we're going to take the square root, and here is where things get tricky. Okay, because when you take the square root, so that this guy equals tangent of theta, you're going to get a positive and -1. Now, you're going to have all of the possibilities where tangent is 1. Doesn't matter if he's positive or negative. So wherever tangent is 1, that's it. And all of those angles are the pi over 4s. Tangent is 1 at all of the pi over 4s, right where sine and cosine actually equal the same number. So this means that theta is going to be at, we'll just go around the circle. Pi over 4, that'll be 3 pi over 4. 5 pi over 4. And then as we go, it would be 4, that would be 8, so 1 less, that'd be 7 pi over 4. I could have just paid attention to the pattern there, but I don't trust that. I like to just try to make sure that it makes sense to me. Okay, all right. So those are my 4 answers. All 4 would be solutions here. Okay, so I'm not gonna talk about what that would mean in physics or why someone would want to know something like that, but let's just make sure our videos stay focused like this. Is this going to be similar here? No. Okay. It's okay. All right. So 18. Did I do this right? -1. 1/3. Yeah. Okay. This is right. Okay. So now I know it's going to seem weird, but let's go ahead and divide everything by -3 first, so we get 1/3. Okay, now I know you're thinking to yourself, well, if I took the square root, the square root of 1/3, where is that on my unit circle? But watch what happens though. Okay, if I take the square root, I'm going to get the positive and negative ones. Okay, but I'm going to get, it'll look like this. So let's write out that first. Okay, and then I'm going to go ahead and go on the other side here, and I'm going to have radical 1 over radical 3. Now I'm not allowed to have a radical sign in the denominator. So if you remember, this ends up being plus and minus radical 3 over 3. Okay, now that is on my unit circle. Okay, so where do we get radical 3 over 3? Now it's also the plus or minus, so this means that I've got every single quadrant is going to get covered here. And so I got to remember where it's radical 3 over 2. So I need the cosine to be larger than the sine, so that would be at pi over 6. So pi over 6. And then we got to go to the other quadrant, so that's going to be 5 pi over 6. Okay, then we go to the next one, that's 6 pi, so we go in one more, 7 pi over 6, and then we're going to go one less shy of 12 pi over 6. So there's our 11 pi over 6. Now I don't have my unit circle to show you, but this basically was right here. Okay. Radical 3 over 3, tangent is that value right here, and so I need this guy, I need that guy, I need this guy, and I need that guy. So all 4 of those are represented here. Okay, now I'm going to do more of these, and I know that this is, you probably want more of the, maybe we'll do a few of these. Anyways, I'll probably adjust this during class. Okay, all right, see ya.